Imagine waking up one morning and discovering that the entire fabric of reality has changed. Atoms, the invisible building blocks of matter, have suddenly ballooned in size, each one now as large as a basketball. That's not just a weird sci-fi twist, it's a total redefinition of everything we understand about physics, matter, and life itself. To start, let's talk about just how tiny atoms actually are. A typical atom is about zero point 0.1 nanometers in diameter. That's a 10 billionth of a meter. A basketball, by contrast, is about 24 centimeters across. If atoms were suddenly the size of basketballs, they'd be 2.4 billion times larger. That's like inflating the marble until it becomes the size of the Earth. Except now, we're inflating all matter everywhere. So what happens to you, to Earth, to the entire universe? Well, first of all, you wouldn't be here to ask the question. When atoms expand to the size of basketballs, the space between atomic nuclei, the very gaps that let atoms bond into molecules, would also increase dramatically. All the intricate chemical bonds holding your body together would snap. DNA? Gone. Proteins? Disintegrated. Water molecules? Shattered into lonely floating hydrogen and oxygen atoms the size of sports equipment. In fact, you'd never get to wake up into this nightmare world. The very instant atoms inflated, all matter would explode apart. Not from heat or pressure, but from sheer incompatibility. Structures held together by atomic forces would fail spectacularly. Buildings would turn into expanding clouds of unbound elements. The air itself would become unbreathable as gas molecules ripped themselves apart, no longer able to bond correctly. Let's say, somehow, we pause the destruction long enough to explore what this basketball atom universe might look like. First, everything would be ridiculously massive. Since the volume of a sphere scales with the cube of its radius, making atoms 2.4 billion times wider makes them over 10 to the 8 times more voluminous. That means even a single gram of hydrogen, normally containing billions of atoms, would swell into something the size of a planet. A single grain of sand, larger than the moon. It gets worse. Matter as we know it would become impossibly fragile. In our world, the vast majority of an atom is empty space. Electrons whiz around a tiny nucleus, held in orbit by electromagnetic forces. If atoms expand, their nuclei don't automatically grow with them, unless we also scale up protons and neutrons, which opens a new Pandora's box of nuclear problems. If we don't scale nuclei, then we've got enormous ghost atoms, like beach balls with a single grain of rice in the middle and electrons flung absurdly far out. These atoms wouldn't bond. They'd barely interact. They'd be the loneliest particles in the cosmos. But let's pretend again. Let's say we rewrote the laws of physics so this new size of atoms is somehow stable. The universe would look wildly different. First off, everything would be incredibly sparse. Atoms being so huge couldn't pack closely together. Materials would become fluffy and cloud-like. Your table? A fragile lattice of basketballs, loosely touching. Sit on it, and it crumbles like dry cake. Pick up a glass of water, and it floats away like fog. Then there's the issue of light. Photons, particles of light, interact with electrons in atoms. But in this oversized atom world, electrons are so far from their nuclei that their energy levels and the way they absorb and emit light would be unrecognizable. Everyday colors might vanish. Maybe all objects look dull and gray, or maybe everything glows eerily in strange ultraviolet shades as new rules of quantum physics take hold. Sound wouldn't work either. Sound needs tightly packed molecules to vibrate and pass energy. In our new atomsphere, everything is too sparse. Say goodbye to music, speech, and footsteps. You'd be trapped in a cricket fluffy void of wobbling matter. And gravity? That's the only thing that might still make sense. Atoms may be huge, but if their mass stays the same, their density would plummet. Imagine a bowling ball the size of a continent, but still weighing the same. Earth, filled with ultra-fluffy atoms, would become dangerously lightweight. It could lose its atmosphere, drift in space, or even be pulled apart by the gravity of the moon or sun. Now here's the kicker, everything would slow down. Chemical reactions, like those that power your brain or air or metabolism, rely on atoms bumping into each other at high speeds. Giant atoms move slowly, reactions would crawl along, fires wouldn't burn, digestion would stall, thinking would take hours. In this world, reality doesn't just look different, it moves at a snail's pace. So what's the conclusion? If atoms were the size of basketballs, the universe as we know it would end. Not in an explosion, but in an unraveling, a cosmic puff of disintegration. Everything that relies on chemistry, physics, light, sound, structure, in other words, everything, would fall apart. But still, it's a fun thought experiment. And it reminds us how astonishingly fine-tuned our universe really is. Atoms are tiny, almost impossibly so, but it's exactly this smallness that allows reality to exist. Our lives are built on the invisible dance of things we'll never see. Unless one day someone hands you a basketball and says, "This used to be an atom,"